Hey everybody. Let's just do some work. Let's work out some problems here from the review number 2. So it says simplify. Use absolute value signs when necessary. Okay, we can do this. So we just have to simplify what's underneath the radical, which is called the radicand. So that's going to be -5 square root of 100 times the square root of v to the 4th. Well, that's easy. The square root of 100 is 10. And the square root of v to the 4th, let me see if I can rewrite it like this. Maybe you'll see it. V to the 4th all to the half power, which then makes this -50 v squared. You see it? Because a power raised to a power, you just multiply the exponents. So what's a half of 4? 2. And that's our answer. Okay, number 2, let's say this is 6 times, well, 343, that goes in 7 times 49 times x. So now we can break it down. So this will be 6 times the square root of 7 times the square root of 49 times the square root of x. So we know that the square root of 49 here is 7, and we really don't have to worry about the positive or negatives here. So this looks like it's going to be 42, right? The square root of this is 7, right? And then what's ever left over in the radicals. You guys okay? Okay, write each expression in exponential form. Well, this is easy. The only thing you have to remember about exponential form is that if I take any base and I raise it to the m over n power, that's the nth root of the base raised to the mth power. In this case, the index number is 2, right? If it doesn't show, we just assume it's a square root. So this is just 7m all raised to the half power, right? Because the exponent on m is 1, right? On this whole thing is just 1. So let's do the other one, yeah? So this is going to be 2n, and it's got to all be raised to some power. Well, it's to the half power, right, because it's the square root, and the number here, 5, is the multiple. So we are now done. Notice we are just following the same pattern. Now we're asked to do some simplifying, and it's the same process as we did before. So all we have to do is use our laws of exponents. So this would be 4 to the 3 halves. Well, you know what? Let's actually do this a different way. You know what? Let's do this a different way. Let's say we have 4k squared, right? And I'm all raising that to the half. Well, I can also raise that to the third power, right? Because as we mentioned before, up here, a power to a power, you just multiply the powers. So 3 times a half is 3 halves. Now, I can clearly see that I'm taking 4 to the half power and k squared all to the half power. And then what we're doing is we're cubing it. So, in other words, what's the square root of 4? Well, that's 2. What's the square root of x squared? Well, that's really the absolute value of k. Oh, sorry, did I say x? I meant k. If I'm taking k squared and I'm raising it to the half power, that's just k. And it really should be the absolute value of k, but because we're all working in positives, I'm just going to write k. And then all of that is raised to the third power. So this would be what? Well, if you don't remember your rules of exponents, you can write them out, right? So this would be 2k times 2k times 2k. So this is 8k cubed. All right, next one we're going to break down the same way. So this is n to the 16th power, and we're going to raise all that to the 1/4, right? Because that's our denominator, that's our index number, and we're going to raise all of that to the multiple that we're doing. So now, very easy, this is just going to be n to the 16th, well, 16 over 4, all raised to the 3rd power. So this is really nice and easy. Well, 16 divided by 4 is 4, and then we're going to raise it all to the 3rd power. So this is the power-to-power rule. We just can multiply them, as what I was trying to show you before, and that would be n to the 12th. All right, now we're looking at some multiplications. We're going to find some products. I'm going to do number 7 two ways. Number 1, I'm going to do it the classic multiplication way. So I'm going to take the first one, take the square root of 2n minus 1. I'm going to take the second one, I'm going to put it in orange. I'm going to say the square root of 2n plus 1. And then I'm going to circle everything here. So I'm going to circle all of the terms that we see. Now, we're just going to multiply just like what we usually do in classic multiplication, except that we're not going to start from the right and work our way to the left. We're going to work our way from left to right. So square root of 2n times the square root of 2n. I'm going to draw it out the first time. Square root of 2n times, in fact, I'll use parentheses, times the square root of 2n. Now, let's use red. This will be minus, right, because negative 1 times the square root of 2n, so that would be negative 2n. Then I'm going to use green, and I'm going to multiply backwards here, so that gives me a plus square root of 2n. And then the last product that we have to have is negative 1 times positive 1, which will give us a negative 1. Remember, now that we have our products here, we can just add them together. Well, the square root, oh, this should have been 2n as well, I'm sorry. So the square root of 2n times the square root of 2n is simply 2n. Well, this is nice. Those are exactly the same thing, but opposite signs, so they cancel out, and then the minus 1 drops down. So the answer to this one would be simply 2n minus 1. Now, I'm going to do this the second way, and I'm going to remind you of the difference of two squares. Okay? And remember, that means that if I have two binomials, then their product is going to be the difference of two squares. So if I have a plus b times the quantity a minus b, it's always going to be a squared minus b squared. So what's a? Well, let's just say this is a right here. So I'll leave that in red, and let's just say that this is b. Right? That's b. So now all I have to do is take the square root of 2n and square it, right? That's a. And then I have to subtract off something else squared, right? Well, what's that going to be? 1, right? Because that's b. So this becomes 2n minus 1, and that's our answer. Yes, okay? All right. On number 8, I'll do by just basic distribution, just so we can see a whole variety of things. And I'm going to take them, I'm just going to rewrite it as it is. And then we'll do the distribution. So square root of 5 times the negative square root of 5, that's negative square, I'll draw it out again, square root of 5. Okay? The next one we have is the square root of 5 times negative 3, so that's minus 3 root 5. Next one we have is negative 4 times negative root 5a. So we'll put that down as positive 4 times, what was it, 5a. Then, let me see if I'm brown, I guess. Then we'll do negative 4 times negative 3, which should give us the positive 12. Now, when we do our simplifying, we know that those two are going to give us negative 5, right? The square root of 5 times the square root of 5 is the square root of 25, which will give us 5. And then that negative, don't forget the negative, right? Excuse me. Then we have minus 3 root 5 plus 4 root 5a plus 12. So now we can just do some combining here for this oh, whoops. I made a mistake. You see it? This one should have had an A. So this is not actually right down here. Mistake. Thankfully, we caught it. Mistake. Okay. Let me just go back. I can actually do this very quickly since we have all the colors already there and everything is there, and we'll make sure everything is the same. So I think we use pink first. That would be the square root of 5 times the negative square root of 5a. Then we used red, and red was the minus 3 root 5, and then we used dark purple or blue, and then that was positive 4 root 5a, right? Making sure. I'm so slow with this method. And then the brown was the plus 12. So now when we put it all together, it's going to change just a little bit. This will be negative square root of 25 times the square root of a minus 3 root 5 plus 4 root 5a plus 12. And then this would give us negative 5 root a minus 3 root 5 plus 4 root 5a plus 12. And unfortunately, that is actually the answer, because we can't combine anything else. There's nothing else to combine. Sorry about that distribution thing. I messed up with that one little a, and we just corrected it. All right, now let's go on to just combining. And this, we just have to simplify. So I'm actually going to pull out the radicand first. So simplify the square root of 45. That tells me that it's the square root of 9 times the square root of 5, right? So when I do this out, this will give me 3 root 5. And you can see that we have the other one too. So technically, we could have done this a couple of different ways, right? But let's carry out the first way as the way we've been working. So this now would be 6 root 5 minus 9 root 5. And that should give us a negative 3 root 5, is what it should give us. Now, can we look at it the opposite way as well, or a slightly different way? Sure. See how the square root of 45 exists in both? So think of it like as an x, like 2x minus 3x. That gives us a negative, x, right? That would give us a negative x. So in this case, we have a negative root what? 45. Once we do the simplification of the 45, right, the square root of 45, we can just simply say it's negative what? 3 root 5. So there's lots of different ways to tackle them, okay? So here's another one, number 10. So this is negative root 6 times 4, right? That's 24, minus root 6. So we just carry this out. root 6, root 4, minus root 6. We could factor out this and do it a couple of other ways, but let's just look at it the regular way. Square root of 4 is 2, so this is negative 2 root 6 minus root 6. So now if I lost $2 and I lost another dollar, I have lost $3, and the dollars in this case should be root 6. Okay? And then the last one that we're going to work on real quick is this beast. You can see that they're all fourth roots here that we're dealing with. So we've got to look for perfect fourth, or I never remember the right word. So 1 to the fourth, 2 to the fourth, 3 to the fourth, 4 to the fourth, and so on and so on. So like x to the fourth, x to the eighth, and so on and so on and so on. But notice we don't have any variables here, so we only have to worry about a few things. So over here, I'm going to simplify the first radicand, which is the 80. Okay, so I'm going to look at, I'm going to look at the fourth root of 80. Okay, so all we have to do is basically factor it, right? And this is an easy one. This is 8 times 10. And then we know that this is really 2 times 2 times 2, so that's 2 times 2 times 2, and this is 2 times 5. So now that we can put the fourth root radical back, or the radical back in place, and then remember it says that we need 4 of something to pull 1 out. So I see 4 2's, so that means I can take 1 outside. So then this becomes 2, the fourth root of 5. So that's really nice. We've got a few things going on now. Now we have negative 2, the fourth root, that's horrible, the fourth root of 5, minus 3, fourth root of 5. So we can do a combination there. Now let's take apart the other one. We're going to simplify the fourth root of 64. Well, 64 is kind of nice. I mean, we could break it down by 2's if you want first, but we could also break it down by 4, right? Because 4 goes into 6 how many times? Well, that's once with 2 left over, so that's 16. And then we have 4 here, and this would be 4 times 4, but we don't have 4 4's, right? So we got to keep breaking it down. This is 2 times 2, this is 2 times 2, and this is 2 times 2. We can now bring the radical back, and now we're looking for sets of 4. So 1, 2, 3, 4. I can pull out how many 2's? Just the 1. So then this becomes 2 fourth root of 4. So now I'm going to just take the 2 and multiply it what? By the 3, just like I did with the 2 earlier and the negative 1. So that gives us plus 6 fourth root of 4. Now all we have to do is combine the like terms, and I'll use purple for this. In fact, I'll use the highlighter. So negative 2 of something and minus 3 of something will give us how many things? Well, if I lost $2 and I lost $3, I have lost $5 of whatever it was. And then we just have this, which cannot be combined with anything else. And that is our solution. I'm hoping this helps. Let me know. Let me know in the stream, comments, Zoom, all that good stuff. All right. Have a good day, guys.